Welcome back again. The topic is written over here, linear charge distribution. As you can see, there is a reference frame ready for us, that is Cartesian coordinate system in three dimension, x-axis, y-axis, z-axis, and this is a blue colored line over which there is continuous distribution of charges. Now, in this case, we toss a quantity. That quantity is called linear charge density, and it is symbolized with lambda. So you can write down that lambda is charge per unit length. So lambda is equals to charge q upon length L. That's it. You have to remember this. That is linear charge density, charge per length. Now from this you can have the unit also of lambda. So unit is coulomb meter inverse. And if you want to go for dimensional formula, let's come over here. We all know that charge is given by M0, L0, T1, A1, whole divided by length, which is M0, L0, sorry, L1 and T0. So we can have lambda is equals to M naught L minus 1 T1 A1. Simple. Again, linear charge density is simply explained as what is the charge per unit length. Okay, while dealing with the numericals, we have to deal like this. We have to consider a small line element, and we'll be saying that the length of the small line element is dl. We'll also say that the charge over this particular line element is dq. You all know it very well that this is infinitely small line element, but that the length is infinitely small, and the quantity of the charge or the amount of charge is also infinitely small. So in this case, we'll use lambda is equals to dq by dl. Stay tuned for more